All right, we're recording. Hey, Nathan, how's it going? Welcome to our first blab for Ocean Talk Friday. How are you?
I'm good. This is pretty cool.
This is cool. I've never done this before, and it's kind of funny because we're doing Ocean Talk. It's normally called Ocean Talk Friday, but it's actually Wednesday because that's when we normally record this because it goes live on Friday. But for all the people who are going to watch, or if people are going to watch at all, we do this Ocean Talk Friday for Speak Up for Blue podcast, and we talk about essentially 4 articles or 4 topics that we found interesting this week that we want to talk about, either from the podcast or articles that we've read, and we didn't get a chance to cover them on the Speak Up for Blue podcast, so we just kind of went on and decided to talk about them, just the two of us, and give our opinions on it. So because we're on Blab, and this does get recorded and it gets shown again and again, and we're going to start doing this on a regular basis. Nathan, why don't you just give a little background about who you are and what you do?
Okay, my name's Nate Johnson. I have a master's in marine biology from Texas A&M Galveston. I'm wearing the shirt now, actually. My research was on systematics and taxonomy, population genetics of invertebrates. So I worked in the marine invertebrate lab. Our shirt, if you can read the back, says support global warming. It was a pretty great pun by my advisor. We're all proud of it. Right now I work for a small nonprofit in Galveston called Artist Boat. I manage habitat restoration projects and land stewardship and more terrestrial conservation.
Okay, right on. That's cool. And for those of you who don't know who I am, my name's Andrew Lewin. I'm also a marine scientist. I call myself a marine spatial ecologist, but essentially marine, but it's a fancy word for marine biologist. And I'm into conservation, and I do have a 9-to-5, but this is the speakupforblue.com is a website that I started and run with Nate. We essentially run it because we want to get more people aware of what's happening in ocean conservation, the ocean issues that are arising, how we can implement solutions to reduce or hopefully eventually eliminate those kind of issues. And really we just talk about ocean stuff, ocean conservation stuff in the ocean, and we like doing this. The speakupforblue.com, we also run a Speak Up for Blue podcast, which is what we're recording for right now, and I believe I will start recording these live and recording the podcast. We're recording these live sessions for the podcast in the future because we want to get more people involved, and it's nice to the more people who watch this as we go along will be able to ask questions and we can answer them on the go and stuff like this. But we run a Speak Up for Blue podcast on iTunes and on Stitcher, and it's just a fun thing we do. We almost have 100,000 downloads. Actually, we have a little bit of a bet that I think I'm going to win of when we're actually going to get 100,000 downloads.
It's not going to be me.
But yeah, so anyway, let's get started with the show. So we're going to talk about some topics that we found interesting over the week. So Nate, why don't you start off? I think we're going to start with the shark one, right?
Yeah, the first one comes out of Scientific American, and it's a story about how sharks navigate through a mostly open ocean. So the thought behind this is sharks are one of the most migratory marine animals, or groups of marine animals out there that travel long distances. If you've ever seen Shark Week or any sort of shark research going on today, a lot of it revolves around tagging them, figuring out where they go during certain times of the year, why they go there. And the one common thread is that they travel up and down country coastlines like it's nothing throughout the season. So, most of this time is spent in the open ocean. There aren't a whole lot of features to really visually navigate where you're going. So researchers wanted to figure out how exactly they find their way to these different sites. And the theory, or the major hypothesis, is that they use olfaction or smell, because that's one of the more potent senses for marine animals. Usually chemical cues or senses of smell are what is most often used in marine environments. So there's a short video. It's a minute and 52-second long video on Scientific American about it, but the original article is on PLUS ONE. It's entitled "Olfaction Contributes to Pelagic Navigation in a Coastal Shark." And the researchers looked at leopard sharks off the coast of California. And to test this, what they did was I believe there were 23 sharks. 12 of them were controls. So they captured them, tagged them, and released them 6 miles offshore from where they collected them. So the idea was you transport them to a new area, you give them a certain amount of time to get back, see how they do. So half of them were the control group, and they released them, and they swam in a relatively straight line, pretty much straight back to the area. The other 11, I believe it was, had, let me get the term right, their sense of smell was obstructed. So they put cotton wool soaked in petroleum jelly in their nostrils, basically block any smell. And after 12 hours, I think, was the duration, they found that not only were they not close to the shore, they'd only made it maybe halfway back to shore, or half as far as the other ones did, but they were swimming in random directions, so it seemed like they really didn't have a clear direction of where to go. So, you know, they think that there's probably something else, because it wouldn't really be evolutionarily responsible for a species to develop just a sole method of transportation and navigation. But what they think is that sense of smell and olfaction seems to be the major guiding system for sharks, and that there may be other things thrown in there if their sense of smell is disrupted. But as you could tell from this study, there doesn't seem to be much other of a prevalent sense of direction, because they're just kind of going anywhere. So it's interesting research, especially with a group as diverse as sharks. And in one of your interviews this week, you spoke with Chris Lowe, who kind of reiterated that we don't know much about them. So any sort of research like this is very important.
Well, yeah, and it's interesting too, because I remember one of the first research papers I read on sharks was actually a hammerhead paper, where they are saying they use the electromagnetic fields in the ocean. They follow valleys to actually, that's how they navigate and migrate up and down the coast. So it's interesting how different sharks use different senses, and maybe not sight, as we would all think that they would, to actually navigate up and down a coast, where, you know, depending on their probably best features, like you said, sense of smell, or with hammerhead sharks, is they can sense electromagnetic fields. You know, you can get, you know, a different approach of how they migrate. And I think it's kind of interesting how they use that best feature, or their most prominent feature, to actually migrate along these lines. So I think it's kind of cool. I mean, what species of shark did they look at?
I think it was leopard sharks.
Leopard sharks, which are pretty small sharks, not very big. It's kind of interesting because they're found along the coast, which is kind of nice, and it's nice to see that a study uses a different shark. Probably these are a little bit more manageable to study and handle. But other than sort of like the big sharks that we see, the quote unquote, I guess you can't see that quote, but quote unquote, you know, man eaters that we see and stuff. And I just think it's kind of interesting that we don't, you know, we don't normally hear stuff on leopard sharks. And, you know, going back to the Chris's interview on Wednesdays, that's what he studies. He studies different sharks, smaller coastal sharks, to get a knowledge of what's happening along the coast. And he has some pretty interesting, you know, topics to study, like the horn shark and things like that. But what do you think about this article?
I like it. I find these types of navigational studies really interesting, because I don't think it's anything that people think about until you think about it.
Right.
And then I think it's a lot more interesting, because, you know, sharks, whales, marine mammals, large fish, anything that migrates a long distance needs a way to figure out where it's going, because they're not just aimlessly floating around. And from the small amount of research that I know, it seems to be a variety of different, you know, tools to do this. Like, it's not, everything doesn't use olfaction, everything doesn't use vision. It depends, like you said, on the species or the group. So I know sea turtles were a group that uses a lot of magnetic field information. Marine mammals like seals, there have been some papers saying that they use the pattern of stars in the night sky to navigate their way. So now we have olfaction. I think for some, you know, shorebirds or other sort of animals, I'm sure vision plays a role in situations as well. So it's something that's really interesting to think about when you think of what type of environment these animals have to adapt to. vision may not play a huge role because there's may not be much of a point for developing strong eyesight. Whereas, on land, that's pretty much the major, for mammals at least, that seems to be the major sort of adaptive sense. So I think these are really good. I think they can provide a lot of insight into management strategies, things that could disrupt, their sense of navigation. It's obvious for whales, marine acoustics are a huge deal, but no one thinks of how changes in the ocean chemistry may affect the olfactory senses of sharks, but it could have, a very significant impact. So I think it's really interesting. I'd like to know more about this sort of thing. I really enjoy reading these homing and navigational studies.
Yeah, I mean, I like it. I like talking about this, especially on the podcast, because this is not something we normally hear about. Just like you said, like the public doesn't normally hear that, a shark will use its sense of smell to actually navigate and get around. When, if you think about it, some of these coastal waters, the visibility may not be good. And scuba divers would know this best, where if you don't have visibility, you can't really go anywhere, or you don't know how far you can go, or you don't know what's ahead of you. And when you're looking at, being a shark or being an animal that can't see, it has to use some of its other senses, because it has to sense not only where it's going, but what's in its way. Are there predators around? Is there food around? What kind of habitat are they in? Cold, what's in the water that will allow them to continue. And I think using that extra sense will actually help them. And sharks have, of course, a sixth sense on top of that, where they can sense, movement by other animals. And I think that is kind of an interesting aspect as well. We just don't normally think about it. We just see them swimming, and we don't know where they're swimming off to. We don't know how they're swimming. We don't know why they're swimming in certain areas. But now we have a feeling like, oh, they use a sense of smell to actually migrate up and down the coastline. That could be very turbid, and we don't normally see that, right? Because we're not in a water that's turbid, so we don't understand that. Hey, no, you can't use your sight to actually get somewhere. So I think that's kind of interesting.
So when you watch the video, it says that they altered the smell by stuffing cotton balls in the noses of these sharks and then released them.
That's kind of weird.
And then they showed the pattern, and they were all over the place. And then the next thing they say, something was like, the researchers assumed that the sharks got home all right. And I was like, this is a ridiculous way to design a study, is just kind of toss them out there and say, they're probably fine. But then it said the cotton balls dissolve after like a certain amount of time, and they're safely back, hopefully, in their habitat. But I thought that was a really interesting way of figuring out how scientists design these types of studies. It's just shove something up their nose, and we'll sure they'll figure it out somehow.
Yeah, well, I just think it's hilarious how that's what they thought of. It's like, okay, well, how do we get them to stop smelling to see if they continue on the same pattern? Well, let's stuff cotton balls.
Yeah, it's like they took an undergrad and was like, here, we're going to try some stuff on you. Tell us when you can't smell anything anymore.
Let's just see where he goes, or where she goes, and see if they're all over campus.
When I was in grad school, I was part of a journal club where we would meet and talk about research once a week. And the theme for 1 year was homing and navigation. So we covered a lot of these papers. And one time we thought it'd be really fun if we did our own study where we'd all go out to a bar in the middle of the city one night, and like 3 people would have noise canceling headphones, 3 people would have blindfolds, and we'd say, like, you got to meet at this person's house.
I could just see you guys on the news. 3 students die because of stupid.
It would be
study.
The people with blindfolds too. Like if you had headphones or cotton balls up your nose, you'd be fine.
Yeah, for sure. But I mean, like, imagine how these sharks must have felt. Totally disoriented, maybe not even able to see properly. And then they, it's kind of interesting how they go all over the place, and then when you take them out, or when they're out, they go back to a normal pattern.
It's pretty
I think that's really interesting. Yeah, I think that's really cool. Anyway, let's get to the next story. We're going to talk about something really different right now. We're going to talk about sea cucumbers.
Yeah, this one is in Al Jazeera, America, and it talks about the sea cucumber. Essentially, it's a fishery. The sea cucumber industry in the Banana Islands. I believe, off the coast of Sierra Leone. And so if you don't know, sea cucumbers are, they are exactly what they sound like. They're little echinoderms. They look sort of like a curled up cucumber. They're closely related to sea stars and starfish. They're a member of that phylum as well. And they usually hang out around the bottom of shallow coastal warmer areas. They feed on a lot of detritus that sinks down, or a lot of small benthic organisms and plankton and algae. In the Banana Islands, there is a small fishery for them because they are seen as a luxury food item in a lot of East Asian countries. They mentioned China specifically. I'm not sure if there are other countries as well. And they're also used in some traditional Eastern medicine. So similar stuff we see to a lot of shark fins and manta ray gill plates. And in the Banana Islands, the locals typically dive for them at night, and they catch enough to make a living. It's not a really high income area, so they don't make a lot of money, but they make enough to support themselves, and they sell it to the Asian markets, essentially. And the story talks about how it follows this one diver, and they interview him, and he says, he can usually make up to maybe $100 in a day in an area where people live on about $2 a day. But then you have these international folks coming in from these East Asian countries who, obviously want to maximize their profits and their revenue, so they always try and find ways to catch more. Right. They use state-of-the-art equipment that allows divers to stay down longer. They use lighting or visual mechanisms to let them fish longer at night. And the locals are concerned, one, that this is overfishing the population, but B, also that, when you have these people coming in from other countries, they're not necessarily coming in with the best sustainable practices in mind, because if they overfish that one area, you'd think they just find another area. Whereas the folks who live there, they don't want to overfish and utilize all the resources, because then they'd have no income. They'd have no way to live off the land. So, the reason I picked this one is because you don't hear sea cucumbers and overfishing in the same sentence pretty much ever. I mean, I don't think you can even technically say this is a fishery, but it's an industry. And they do mention that there's some scientific data to show that around the Banana Islands off the coast of Sierra Leone, sea cucumber populations have dropped, and they are a really important primary consumer in the area, so they play an ecologically important role. And it's just a very sort of condensed example of, I think, a lot of the same situation other areas and other ecosystems are facing, whether it's with overfishing sharks, overfishing fish, overfishing lobster. It's the same general idea. You have people who are focused more on revenues and profits to the point of not sustaining their business for the long run. And you have locals who may practice the business, but really don't want to see it overfished and overharvested. So I thought, this is just kind of an example of that. It's the same conflict we're seeing is happening in a variety of different locations and a variety of different ecosystems, but the general conflict is the same.
Yeah, no, I mean, we see this often, right? It's almost like when somebody has something good, locally, and it's really working well, somebody comes along with a bigger and better idea, saying, hey, let's make this huge, let's make a lot of money off this. We can serve this market and such market. And of course, when you're serving the Asian market, there's so many people that are there. Now you're looking at a huge market, and they love different things. The Asian culture is based, especially the food culture, is based on like tastes and and texture, so very different texture. And if you've ever seen a sea cucumber, I mean, there's some different descriptions for it, but it's a kind of an interesting animal that has a very interesting texture. And I know in Canada there's a fishery for it, and other places as well there's a fishery for it. And I think it's just one of these examples where you're like, holy cow, we've got something nice going on here, and we can supply our own food, or we can supply our own market. And then all of a sudden you're like, okay, now let's just totally expand this market and serve a different market, and we're going to basically fish this till it's gone. And it's just, once you do that, you're like, this is BS. Like, why are we doing this? Why are we ruining such a small little fishery that's probably sustainable, probably managed pretty well, and expand it to something that gets out of hand? And unfortunately, it's this local community that pays for it. And I think we see this over and over again. And I it was interesting. I was talking to Chris Lowe about on Wednesday about this. Is we should keep this revitalization of small fisheries, artisanal fisheries, keep them small and keep them local, and allow local communities to be able to not just exploit but survive a sustainable livelihood off these areas, instead of expanding and getting greedy and trying to make more money and then losing that fishery. Right? I think we see this. We just see it too often.
Well, and that's why you have disciplines like natural resources management, because when you're managing an industry that relies on, all goods are scarce, but a scarce good that also plays a role in a system that you can't easily quantify its value to, then extracting it or over harvesting it isn't just like, you're running out of some piece of technology. It's like you're running out of a vital resource that you can't necessarily replicate. You don't necessarily understand the ramifications of losing it. So, it's harmful on a variety of levels. It's harmful from an ecosystem perspective. It's harmful from the perspective of the local economy. It's harmful from a diplomatic perspective, because I can't imagine, whatever sort of regional government might rule over the Banana Islands. I'm sure they don't appreciate having international folks coming in and disrupting a system that's provided a way of life for a lot of the folks there. So, I hopefully we'll see these types of things, like you said, get smaller. I think that's kind of the only way to really mitigate this, because the demand isn't necessarily going to change. You're going to have to find a way to reduce the amount of supply you're bringing into the industry.
Yeah, absolutely. And to be honest, I think when a fishery like this happens, this is where I think organizations like nonprofit organizations can really help out. When you have an artisanal fishery like this, it's always good to almost partner with the local community to monitor what they're actually bringing in and what the actual population or the actual food or fishery that they're trying to do. Monitor that population or that community and look at the effects. And then if you look at the effects and you say, hey, if you guys are doing things sustainably, but somebody else comes in, you can actually almost set quotas or almost set limits to say, hey, no, you can't come in here because you're going to completely disrupt this fishery, and this local community is going to see a collapse of this fishery because you want money going elsewhere. Because a lot of times it is international, people coming in and saying, hey, you've got something good going on. I want in. I'm going to offer you this short-term gain, and I'm going to take all this stuff, but the long-term consequences are going to stay with you, even though you have this short-term gain. And I think by monitoring and using science and just sort of population structure or stock assessment, just very basic scientific monitoring, you can actually help these local community out, even just teaching them to empower, what they're doing and going from that perspective, I think would really help out. This is just thinking off the top of my head, but there's a lot of organizations out there like Oceans Watch that's based in New Zealand. And I think now they're based all over the world. They have offices all over the world, but they go into local communities in like the South Pacific, local islands, who don't really have the expertise or the knowledge to monitor populations or establish marine protected areas. So they come in, Oceans Watch comes in, and they teach them how, okay, here's how you set the boundaries, here how you do like a reef check survey for the reefs, manage, populations and just kind of overall health of the reef. And all of a sudden they empower them, and they have these managers or these monitors that go out there and monitor the reef and secure and enforce the boundaries of the marine protected area. And they all of a sudden they have this empowerment of this community, and they take it into their own hands, and now they monitor whether it be a fishery because they need to survive off of it or anything like that. And I think organizations like that play a really big role in establishing this empowerment of this community.
Yeah, I agree. I think monitoring, and we'll talk about this later. I mean, monitoring is one of the more difficult things to do for any sort of, ecosystem or, marine protected area, monitoring and enforcing it. But it's incredibly important because that's what gives you information to take proper steps forward. So I agree. If you have a nonprofit or some other sort of NGO that has the capability to do this in these countries, you can really do a lot, not only from a research point of view, because you'll have more scientific data, but from a policy and management point of view, you can empower the local community, like you said, and that's ultimately how the change is going to come about.
Yeah, no, absolutely. Absolutely. All right. That's a great story. When I first saw that story, I wasn't sure how much we would talk about it, but that was a good one.
Yeah.
I like that one. All right. Well, let's find out what whales do at night. That's what the next article is all about.
The short answer is we still don't know, but we know a little bit more than we did before. So this is again from Scientific American. It's just a story covering a variety of different endeavors to try and better monitor and study whale populations, specifically larger threatened ones like the right whale. They talk about the blue whale, figure out what their behaviors are after the sun goes down, because most, if not all of the data that we have was taken during the day. So, from a theoretical point of view, a lot of these whales are plankton feeders. So we've talked before about how plankton do these diurnal migrations. They tend to stay lower in the water column at deeper depths during the day, but then at night they come up. Theory is to feed, to escape predation. It's not well known, but it's a very common thing to have these diurnal migrations. So anything that feeds on plankton, usually you see a similar behavior. So fish that feed on plankton, invertebrates, they'll rise up also during the night because that's where their food is. So they just kind of assume that whales go through similar things, and that maybe they're less active, maybe they're deeper during the day, but at night they probably rise closer to the surface, and they probably feed on plankton. Now, since we have more technology to be able to monitor these things, so they mentioned infrared cameras, digital acoustic tags, that sort of thing. They found that they do seem to be actively feeding at night, but it really depends on the species. So blue whales, for example, I think they mentioned, said that they typically are more sedentary at night. They don't necessarily feed. They're not diving a whole lot. They're just kind of hanging out on the surface. And that's one reason why you see blue whales are very susceptible to boat strikes, because they're not really active. They can't see the boat coming, and the boats don't really see the blue whales because it's at night. So they're a lot more susceptible to boat strikes. Other whales, let me get the species right real quick. Right whales, they didn't find a clear trend showing that right whales actually do feed closer to the surface at night. But they did find that they were more active. So what they think is that they are feeding, but these general diurnal migrations that we're seeing at lower depths to larger depths may not apply for right whales, because they may be diving deeper than a lot of recording equipment can actually monitor. So there is evidence to suggest that they're feeding at night, which suggests that they're active, and maybe they're saving up more energy during the day. But they didn't really find any evidence to suggest that they feed just at the surface, which makes it difficult from a conservation perspective, because if you don't know what depth they're typically at, it's difficult to implement protective measures. Right. You can't necessarily say your nets have to be this depth, they can't be any deeper, because that's where whales feed. It would be pretty difficult to just say, get rid of any sort of activity in these areas. But all these researchers are optimistic that as we get more technology, as we get greater capacity to study these whales, we'll have a better idea of what they do for half of the day, which the fact that we don't know this shows kind of what sort of research gaps are out there.
Yeah, I agree. What's interesting is, you talk about the cameras, the infrared cameras who can't see, too far into the depths at night. What's interesting is when I was talking to Chris, I know we've been mentioning Chris Lowe a lot, but he's really into technology, and in the interview he mentioned that he's having this robotic instrument being built that will stay behind a shark, and will track its movement. So the shark will be tagged. It'll track its tag. It'll stay about 100 yards back, and it'll track which way it moves. It has a camera and so forth. I wonder if that sort of robot would actually help monitor whales as well, marine mammals, at those depths at night. I don't know. I don't know the full details of it, but I think it would be kind of interesting to find out, right? To see how deep these animals go. And I mean, it's an interesting question. Like, what do whales do at night? A lot of the research is based on sight and how we wait. I remember doing marine mammal observing, and sometimes you'd see a marine mammal, they'd dive down, and then 20 minutes later they'd pop up somewhere else, and that was another sighting, and then we would record that sighting and where that sighting was, and that's how we would record things. And I know you can tag them, and people have done that, and I don't know the rules around that, especially in the U.S. with the Marine Mammal Protection Act. But I think it's interesting how you can use this technology to find out more about them, and to find out stuff at night with usually when we record information on something that's always visual based. To find out something at night poses new challenges, but definitely questions that I think we need to answer, because we don't know what a lot of animals do at night, let alone marine mammals, right?
Yeah, no, I mean, you're exactly right as far as how difficult it can be to sort of get this type of information. I think a lot of people just kind of assume, whales and sharks are so popular, we probably know everything there is to know about what they do and when they do it. But then we actually try and think of, like, okay, if you were designing a study, how would you track a whale? And, like you said, there are certain tags that, if you're in the field or you have knowledge of these things, you might be able to go out, stick a couple tags on. I don't know either what the type of regulations are, but a lot of these tags can only stay on for so long. So best case scenario, you may just get like a week's worth of information, which is still very good. But, you got to think that unless you have a really fancy camera that can measure water quality, acoustic information, and have video on it as well, you're only getting a portion of the story. So you don't necessarily know what's influencing these behaviors. So up to the point where we had tags, right, all we could really do is go out on boats, wait for them to come up, say, oh, there's a whale, maybe we can figure out where it's going next. But it's not like we have a team of scuba divers who are just all the time following these whales around. So yeah, there's a huge amount of information we don't know about them. There's a professor at A&M Galveston who studies marine mammals by, he does a lot of videography. So he'll try and attach like video cameras to certain marine mammals or animals and try and get their feeding behaviors. And he gave a seminar once. Yeah. It's probably one of the coolest things I've ever seen. But he showed a video of, I believe it was a humpback whale that they tagged. And they put it on the dorsal, the top side towards the tail fin, towards the fluke. And so it recorded for a little bit, and you could see the rest of the tail because it's facing backwards. And it was a group of humpback whales around it. And they must have noticed that something was on that whale, because after like a minute or two, their tails just started hitting the whale till the camera came off.
Really?
And yeah, really? And so they lost the camera in the process, which was probably like
lost the camera, but got valuable information on how a pod will take care of itself.
I mean, like
what is on your back? Let's get it off. Slap them. Let's get rid of this thing. I don't know what it is, and then all of a sudden it's gone, right?
Granted, I mean, there's not any scientific data to show that they definitely knew it was a camera and they were trying to get it off. They could have just beaten up on the whale, but I mean, it was really surprising because the professor was saying it was right after they put it on. It was right after the boat seemed to go away, so they kind of went back to their natural behavior. And yeah, they just knocked it right off. So I don't know how difficult it would be. I've never studied acoustic tagging. I've never done any of it, but I have some friends who say,
Yeah.
if you can get a few good tags in any given study, ones that actually stay on, ones that actually give you reportable data, that is a win. So it's not a guarantee that just because you put a tag on something, you're going to come back with some information.
Especially when the tag is on the outside of
Yeah.
the body, like it would be on a marine mammal. I know the place where I work, they do tags, but they insert the tag inside the belly of the fish, obviously safely, and it doesn't harm the fish, but that ends up staying in longer. Whereas, like, if it's something on the outside, then yeah, it can get hit off, it can get scraped off, it can fall off on its own. They're not designed to stay on forever, so that the animal doesn't have it on forever. So there's a lot of things that take place to make sure that this thing doesn't stay on this marine mammal. So you never know. Sometimes, when I was talking to Chris, he was talking about tags staying on for 24 hours. And then you have to go retrieve the data and bring it back to record it. So, a lot of these things, you're not getting a long-term data set for one individual. You're just getting short-term data sets. So the technology is there, and it allows us to see where they go, and maybe, with other parameters, allow why they go there, allows us to answer that question. But for the right now, we just kind of know their movements during specific times of the day. Especially for visual kind of observations, like what a lot of marine mammal surveys are all about. So that's quite interesting. I like that story. So so that's good. This is kind of cool. We've had a couple of viewers come in and out, but I didn't so if you see me kind of distracted, just to let you know, I'm actually posting it on Facebook and on Twitter and stuff like that. So I'm trying to navigate this blab kind of layout and listen to you as well. So I hope I'm not looking too distracted or anything like that. But let's talk about the last story for this recording, I guess, or this blab in our podcast. But we're going to talk about something different. It's not necessarily an article, and it's actually based on the conversation I had with Dr. Chris Lowe on Wednesday, this past Wednesday. So that would be session 119. So if you want to go to look at that article and listen to that podcast, you can go to speakupforbblue.com/session 119. Okay, so 119. We talked about a lot of different things, and near the end of the podcast and afterwards, we had a conversation, and we had a conversation about how science and conservation is predicated on the doom and gloom. We talk about things that are going wrong. Scientists making observations. We highlight things that are going wrong so that we can correct it, or that we can have people understand it, so that the proper tools can be put into place, whether they're policy tools or regulatory tools, or just educational tools, be put in place to rectify that problem. And now and we talked about how maybe funding is a lot of scientists are funded because of that reasoning. So they'll say, we talked about sharks on Wednesday. They'll say, oh, this species of sharks, say hammerhead sharks, are not doing very well. We need to study more, and we need to study why, which is a very valid reason. But it seems like, and they get funded for it, it seems like that is really the only way you can get funded. It's almost like a scientific business model. And I find now we see a lot of that, but we don't see a lot of, Chris and I were talking about, we don't see a lot of, saying we need to assess this species to see how well it's doing. We have all these tools in place, whether it be directly affecting those species or not. But we want to assess, we want to get funding to do a study to assess what's happening and how well they're doing, how their population is doing. Case in point, the great white sharks in the Pacific, in Southern California and along the coast of California. They're actually doing really well. They're doing better than expected. And Chris was saying he didn't know why they were doing so well. He didn't understand it. He looked over the numbers over and over again, looked at different things. And what he noticed was, in the interview, he said what he noticed was, marine mammal populations were up, sea lion population, which is their major prey. That was because of the Marine Mammal Protection Act. When sea lions back in the 1920s, there was only 2,000 of them. And then when the Marine Protection Act came in the 70s, it just, now their population just went nuts, because people weren't killing them, fishermen weren't killing them when they were around their fishing nets and everything like that. so you couldn't harm marine mammals, which is their major food source. Then you have the Clean Water Act. So now you have coastal populations that are doing a lot better because the water is a lot cleaner. And he said that you forget, we don't know because we weren't around in the 70s, but we didn't realize how bad the water quality was, especially along the coast in the 70s. And this Clean Water Act actually, did a lot of good for the water quality. We just don't realize it because it's a lot better now. And we tend to forget how bad it was back then. So all these tools that were implemented for different reasons have actually played a big role in allowing the great white shark population in the Pacific to actually do very well, or in the U.S. to do very well. And so, it's interesting to like, if you came out and you said, I guess what Chris was worried about is if you came out and said, this population is not doing well, and constantly saying these populations aren't doing well, this community is not doing well, this habitat, kelp forests aren't doing well, all this stuff is not doing well, the people in the House of Commons or the government would go in and say, well, let's start to peel back the Clean Water Act or the Marine Mammal Protection Act because populations aren't doing well. It's not working. So why are we spending all this money, taxpayers' money, to actually put these tools into place if it's not working? They can actually do that if they get on this track that these populations aren't doing well and these tools aren't helping them. On the other hand, people are probably worried about. Actually, before I go on that side, what do you think about that thought process?
I think you're right. I think it exists. I know. So I mentioned earlier, a lot of my job is land management, and we've noticed with a lot of, and it's not just my organization, it's a lot of organizations around Houston and the Galveston area. I've noticed that you can write grants that say we want to conserve 500 acres of land or something like that. Right. And that's usually a pretty safe grant. It might be expensive, but everyone likes to save land. It's very easy. Yeah. Or I shouldn't say that. It's not very easy to do, but it's relatively.
If it was easy, everybody would do it.
But it's relatively easier to get funded, that project, than a project that says we've saved and now manage 500 acres. We need money to keep it going because, that's kind of monitoring, that's kind of upkeep. It's not a sexy thing. Grants don't necessarily want to fund that, but it is just as, if not more important, because, and it goes back to what you're saying about, I think people who fund research sometimes aren't even scientists. So there's that goes into it. But other times they know that the funding is limited, so they want their money to go to the most drastic, important need that they can think of. And a lot of times these days, the most pressing, drastic need is saving species, which are saving ecosystems, I'm not saying that it shouldn't be that. There's a lot of research out there focused on how to protect certain things that need to get funded. But then you're right. You have these studies where, we really need to find out how is this population doing. Really need to do something that's more of a basic stock assessment to verify that this protective measure works or figure out that it doesn't work and that something else will work. And I think it comes down to people don't want to pay money to fund something that may just help them what they thought already existed. So, for example, with protective sharks, if you put out a study that says we want to monitor great white shark population because there's anecdotal evidence suggesting it's doing quite well, and you come back and you say, yeah, it's doing great for these reasons, they would say, like, well, that makes sense. Did you tell us something we didn't already know? And, from a scientist's point of view, yes, we definitely told you something you didn't know. But from a public's point of view, we told you something that you probably could have guessed was the reasoning. And there's a difference there. And so I think if you can develop a study that shows something new that people definitely don't know or definitely don't know how to do, like how to protect a species, you're more likely to get funded than to say something like, we need to just confirm or potentially re-examine this thing that has gone, as we've looked at before, but now we have new technology, we can look at it better. So I think it just comes down to those types of decisions, that if you only have $1 million to distribute to research and you have one researcher saying, we need to protect this dying breed of coral, and you have another researchers saying we need to monitor how coral reefs have done over the last 20 years, you can make the argument that they're equally important from a scientific and political or management perspective. But one of them is going to tell you, oh yeah, they're doing fine, thanks for deciding that we shouldn't fish this method, this destructive method. And the other one might say, we found a way to save this coral species. So I know that was kind of a rant, but I think that's sort of how I feel about why that's the case. I'm not justifying it. I don't think that's a healthy thing for, a healthy pattern for research to have, but that's how it seems to me.
No, I agree with you. I think, there's valid points to look on both sides. You're right. If there is, a project, let's say there's two projects in front of a funding body. One project saying we just want to find out how well this species is doing, or this habitat, or whatever it is. We want to find out how well it's doing. There's some evidence that says, oh, hey, this could be. And then we want to find out, or the other is, hey, this species or this habitat is not doing very well. We need to monitor it to find out why, and then look at policy changes or recommend policy changes to say, this is why it's not doing well, this is what we need to do. The one that's in trouble is probably going to get funded, and that makes sense. It definitely makes sense. I still think we need to, I think these studies go on. I don't think they don't get funded, but I think we need to communicate it better. From a communication standpoint, science communication standpoint, from a Speak Up for Blue standpoint. We need to communicate saying, hey, this, and we do it to a certain point, because when we find those articles or we find those papers where it's saying, hey, this population is doing well, we've discovered something new and how to manage it, it actually works out. Yesterday's podcast, Thursday's podcast, I talked about the La Plata dolphin, the species, the species that was actually featured in Argentina, where the dolphin got plucked out of the sea and passed around and ended up dying. And it was just a tragedy, but I decided to look at, oh, hey, here's the research on it. And it actually says they found out that there's more genetic differentiation within the population, and that has implications for management. That is a good study, and we need to take more time to communicate that, as science communicators, you and I and the rest of the science communication community. And I think that's sort of, I think, what we need to focus on a lot, instead of just saying, hey, this is a problem, this is how you solve it. It's like, hey, these tools that we worked so hard to put in place back 30, 40 years ago, and even, it actually works. So the tools that we're suggesting now would probably be even better to make these populations or fix this problem down the road. It may not happen tomorrow, where the solutions come in place, or we see the benefits from those solutions, but it's going to happen eventually. And if we put these tools into place, and we can actually do it. So it kind of gives us a case to, make more regulatory tools, or implement more regulatory tools, or even just educational tools to get people to act. And I think instead of just people saying, oh, well, no, it's just doom and gloom, I'm going to throw up my hands and that's the end of it. So I think there's a lot of different ways you can look at this. And on the other hand, you can look at the public looking at a population doing well, say great white sharks, and then all of a sudden they're like, well, if they're doing so well, we have so many of them, we see so many, they pose a danger to us. You get some crazy politician, which there are many crazy politicians out there. They can all. What's that?
Not in the U.S.
No,
not only sane people. We're proud of it.
Yeah, sure. Yeah, okay. But yeah, you get like this crazy politician who all of a sudden says, well, no, we got to get rid of the shark, or we got to hunt the shark, and because it's doing so well, and all of a sudden put something else into place that is the opposite. There is that scary scenario as well. So it kind of works both ways. But I just thought it was something interesting to bring up and to think about. But I do think as communicators, we need to bring that out more, to tell people, hey, these tools that people fought back in the 70s and the 80s to implement, they actually worked. And they actually worked really well. And we're seeing the benefits now. So if we put in more things for climate change and reduction in carbon emissions and things like that, we will see the benefits maybe 10, 20, 30 years down the road, but there will be benefits. It just won't happen overnight. And I think people need to realize that, but there is hope in the future.
Yeah. And I think, we this goes into even a deeper discussion, which I think would be worth having at some point, about the differences of applied science and basic science, or what kind of term basic science, because, you know, even studies, for example, the one we keep bringing back about, you know, let's monitor the Pacific white shark population, that I would even consider applied science. I mean, you could very easily connect why that matters to future policy and fisheries and, you know, all that sort of thing. But then you have this whole other branch of science, and I think the reason I focus on this is because a lot of my graduate school work was essentially basic science. My research was looking at sipunculans, which are these small peanut worms, and speciation within them. So like these two populations look exactly the same, but we think they're different species. And I found it really fascinating, but even other people who aren't within grad school would be like, why are you studying worms? You know, are they an important food source? Are they endangered? Like, what's going on? And I was like, you know, I'm sure they're relatively important. They're not endangered. We just want to know this. And that's kind of that's the theory behind basic science, is you do it for the knowledge you gain, not because it necessarily is going to tie into some other thing. And, you know, if you do research on it, there's a ton of really amazing things that have come from basic science. The ability to replicate DNA, which comes into a huge range of research and medical practices nowadays, came from someone just poking around at bacteria and figuring out how they replicate. So it goes back to what you're saying, in that there's a lot of science that may not be easily tied to applications in the next couple years, which a lot of times is how these funding decisions are based, because they don't know what their budget's going to be 10 years from now. So they might have to pick something that they know will have a measurable impact in a year or two. But that doesn't mean that there's not really important science that doesn't have huge ramifications over the next 10 to 20 years. We just don't know it right away.
Yeah, and you're right. I mean, there's definitely, you know, when you talk to a lot of the public, they want to know how research is applied to regular day things. And actually, you even see that now with politicians and looking at NSF funding, where there's Republican politicians who are saying, well, why is this getting funded? We don't need to fund this kind of stuff. We don't need to know about this kind of stuff. Government shouldn't be doing this, which is absolutely false. You know, government should be doing research, should know more about its oceans and its coastal waters and what it manages. It could have serious implications. Now, of course, there's a lot of applied research when it comes to government, because it's an applied, you know, format. You know, you have to make sure you protect certain resources, fisheries, biodiversity, and so forth. But the public really gets into that kind of stuff. And I think doing studies where you're looking at evolutionary strategies of different animals, you're looking at genetic differentiation between populations, that could have an implication for specific species or habitat or whatever you're looking at. But it's also knowledge. I mean, science is knowledge of, and especially marine biology is just knowledge of the ocean and the species that live in it and why things happen. And the more we know, the more we can extrapolate. I mean, you never know. You never know. Those worms may have some kind of human application after a while, right? But you would never know that if you don't study.
The thing is, like, because a lot of people have asked me that, and that's what a lot of people say. Sometimes I feel like they say that to kind of make me feel better, like, you know, we never know. But the point is, you're right. We may never know. They may have some really important application to this cryptic species work, but even if they don't, that doesn't take away from the importance of it, because, you know, I think while obviously it's great to sort of hit the jackpot with a basic science research study that changes science over the next 30, 40 years, you're not going to have that every time you develop a basic science project. So if you know, sort of measure it by the impact that it has down the road, I think you're going to narrow the amount of projects that get funded. And while, I mean, I certainly understand the need to, you know, if a government's going to give you money to fund a research project, you should have some sort of way that it benefits the government. So I understand the need for that application. And the whole point of science is to further benefit, you know, our society and learn more about how we can better manage these areas, and sometimes just, you know, learn about the natural systems. But when money's involved, you got to find a way somehow to apply it. The tricky thing is just just because something doesn't have a measurable or necessary impact now doesn't mean that it won't later. And it's just kind of a slippery slope to get into by measuring something based on its application to something else, I think.
Absolutely. No, I completely agree. This has been awesome. I like this platform. I like Blab. We had a couple of people pop in and out. Yeah, I think if we do this more naturally, I got props. I'm gonna give you props too. This is kind of cool. I think we're looking at things. This is a kind of a cool way of interacting with people, and over time, hopefully people will start attending these things. And this is kind of a bit of a test, and it's been kind of fun. It's nice to be able to have a platform where we can interact and look live. Actually, the stream was pretty good too, and we're recording this, so this has been fantastic. Of course, we're going to repurpose this for the podcast. So if you're listening to this, that's not live, you're not going to miss anything. And if you're listening to this afterwards and you want to, take this on the road, you can do it through the Speak Up for Blue podcast. Go to speakupforblue.com. www.speakupforblue.com/podcast. You can subscribe to our podcast, and we do 5 days a week. Ocean Talk Friday happens obviously on Friday, but we record it, on Wednesdays, just for our schedule purposes. And so this has been amazing. We've had some great topics to talk about, and we're going to continue this. I think this is going to be a regular. I think I'm going to try and record Speak Up for Blue podcasts on Blab. Because the way I see it is this, I don't have a lot of time, but this actually doubles my benefit, doubles the platform, a podcast platform and a live platform, and I use the same effort. I kind of like
it's great because when I was messing around with Blab earlier, there's a lot of stupid stuff on this website. So any sort of intelligent, formalized podcast where one of us doesn't have a flat brim cap tilted sideways and doesn't have a blacked out screen dropping the F-bomb every few words. I think it's a positive.
I think so too. I think we're contributing to some good content.
Thank you for
no offense to the people on the Yeah, absolutely. And I've actually the way I found it is actually through some business podcasts who actually use this as a podcasting, like an interview style, and they use it because you can record the video and the audio, which is we always do. So it's kind of nice that way. So, but yeah, this has been awesome. So we'll end it here, and of course there'll be an outro for the podcast. But I'm gonna start doing this on a regular basis. I haven't figured out a good time to do it because I want to do because I do 5 days a week. I want to do, okay, let's see what time I can do it at. Is it 9 o'clock every night? Do I do Sunday, Monday, Tuesday, Wednesday, Thursday? How does that work out? How does the schedule work? How do we work, Ocean Talk Friday in because we record it on Wednesdays? Maybe we'll just do an Ocean Talk, and then on the podcast it'll be on Fridays, and on Blab it'll be live. So, but we'll see. We'll see how it works out. But it looks good.
I like it. It's a good idea.
Right on. All right, so I'm going to stop the recording, and I'll do an outro so you'll hear more about me if you're listening to the podcast. And if you, that's basically it. So I'm going to stop the recording right now.